Responde is a 3-year project funded by the European Union Horizon 2020 Research and Innovation Programme. 34 partners from 13 countries are developing holistic and easy-to-use solutions to improve first responders' efficiency and safety.
In the project, we develop a variety of advanced products and services which fall under the following categories: augmented and virtual reality technologies, sensors and smart wearables, robots and aerial unmanned vehicles, and modern mission-critical communication systems. All these technologies are integrated in a common platform and work together to maximize first responders' capabilities and safety during mission. Testing of the project technologies in real-life scenarios is critical not only for familiarizing practitioners with the developed tools, but also for validating the platform under real conditions, receiving feedback and fine-tuning it. 3 pilots are being conducted based on specific use cases: a wildfire in Cyprus, a severe earthquake in Greece, and a fire and oil spill at the port of Valencia in Spain.
The involvement of the end users lies at the core of our project development. Through these training sessions and also through the pilots, we allow them to get familiarized with the tools, and this is all done under some operational environment, under controlled conditions. This way they can validate and provide feedback to the technology suppliers so that the technology suppliers can continue to improve and fine-tune the technologies for the future.
In Responde, we develop sensors and smart wearables that can be deployed in field to collect critical data. The data can be monitored directly by first responders and can be transmitted to the command and control center in real time. We have 2 different types of sensors: health sensors and environmental sensors. Health sensors measure breath rate, heart rate, stroke risk, carbon monoxide blood poisoning risk, and movement of first responders. Environmental sensors measure air temperature, oxygen levels, various toxic gases, and nuclear radiation. We also develop other smart wearables, such as an indoor tracking device that detects the position of first responders inside buildings, a portable data logger that gathers information from all sensors and transmits them to the control and command center, and a portable alert mechanism that is triggered whenever a sensor reaches a set threshold. Finally, we have an innovative triage system for tagging and tracing victims of a disaster. The system allows the mapping of the crisis scene and identification of the most critical cases for emergency help with the use of smart wristbands.
Augmented and virtual reality technologies have a lot of promising applications in the field of disaster management. In Responde, we are experimenting and assessing solutions to allow for responders to access and visualize sensor data, as well as critical geospatial elements such as location of a responder, risks, the distance to them, and having local area maps. Getting access to this kind of information allows them to have better overview, better situational awareness, and make better informed decisions. We are also working on immersive and interactive solutions to allow crisis managers to facilitate the supervision of operations. Finally, the project is also working on a social viewing platform that allows a collaborative inspection of videos captured in real time.
Communications is one of the most important aspects to respond to a crisis. That's why we aim to deliver mobile connectivity based on 5G broadband technology and 3GPP mission-critical standards. This means that even in remote areas with bad or no connectivity at all, first responders can effectively communicate together and to their chain of command using rich data, such as video and image. The platform is fully in line with current standards and is compatible with existing devices such as smartphones and tablets.
In Responde, we design highly flexible and adaptable backend applications to aid crisis managers to make better informed decisions by providing real-time information from the field. These highly secure and flexible platforms can be adapted to disasters of any scale and to different types of first responders, including law enforcement, security, firefighters, and emergency medical teams. By gathering information from the personnel engaged in a mission, as well as on the hazards, these applications can provide crisis managers with common operational picture of the disaster scene. By using this innovative solution, crisis managers benefit from improved resource and disaster area management, as well as better planning. These platforms can also be used for training purposes.
Unmanned vehicles such as drones and robots have a lot of potential in rescue missions. They can perform a wide variety of tasks for the disaster scenario, and in some cases even act on the behalf of humans whose lives are no longer put at risk. In this project, we use the drones to provide live aerial view as well as reliable 5G and radio connectivity to remote areas. This allows the first responders to be continuously connected to their chain of command. We also develop drones based on AI technologies, which allows for detection of humans, fires, smoke, and other objects. The drones and the robots used in the Responde project are highly customizable, and they can be mounted with various types of payloads. For example, sensors and cameras, which provide real-time disaster visualization and localization. Additionally, our rescue robots are controlled remotely, but can also navigate autonomously, continuously providing critical data from the disaster scene to the command and control center.
At the heart of this platform stands DFF, or Data Fusion Format, a key component that unifies all those various products and services involved in the project. DFF receives data from heterogeneous sources, such as sensors and wearables that are worn by the first responders or are mounted on unmanned vehicles that are deployed on the field. This data is then homogenized by DFF as a tool and then is provided as available to crisis managers in real time through various innovative backend software and applications that we developed throughout the project.